Welcome back to Lesson 3. You are free to review this PDF where we define the sine of theta using a right triangle. Sine of theta is the opposite divided by the hypotenuse. Cosine of theta is the adjacent divided by the hypotenuse, etc. Everything you know already. Let's go to the absolute value. The absolute value is defined how? What is the absolute value of the number 3? Is 3. What is the absolute value of the number minus 3? The absolute value of the number minus 3 is 3. So the absolute value is a function that when x is positive, the value is positive. When x is negative, the value is minus the value. So, for example, the function will look like this. When x is positive, let's say 3, the value is 3. When x is negative, let's say minus 3, the value is the minus of the minus 3. The minus of the value of the minus 3 is 3. When it's minus 2 is 2. When it's 2 is 2. So and when it's 0 is 0. So the absolute value of x is a function that the graph is like this. This is y equal the absolute value of x. So the absolute value of x is x when x is positive. Is minus x when x is negative. Is here, okay? Is here. I think you know the absolute value. This is a definition that we need to use when a function is 1-to-1. Is 1-to-1 is for every y exists an x. 1x, only 1x. So if to each value of y, of the y value in the range, correspond exactly 1x in the domain, one value in the domain. When f is even when f of minus x if f of x. This is the function f of x equal x squared. This is an even function. And when it's odd, when f of minus x is minus f of x. For example, the function f of x equal x cubed is odd. Well, this is the right triangle. I think we will review everything in class. 360 degrees is 2 pi, but this sign is not correct mathematically. This sign equal is not correct. Because let's go to define what is 1 radian. 1 radian, 2 pi radians. First of all, radians, 2 pi radians, and 360 degree. So the equal sign, it means that it corresponds. 360 degree correspond to 2 pi radians, meaning that you go around the circle 1 time. Okay, this is also one identity. This is Pythagoras theorem, sine square of theta plus cosine square of theta equal 1. This is one identity we will review in class, cosine of minus x. If you take the circle of radius 1, so this is the angle x. Cosine of x is this part of the triangle, and if you take the angle minus x is this angle, you will see that it has the same cosine, this part. So cosine of x and cosine of minus x are the same, and you see sine of x is positive. Sine of x is the opposite. This is a circle of radius 1. So this is sine of x, and as you see, sine of x is equal to minus sine of minus x. So sine of x is like this, going up, sine of x. And sine of minus x is the negative value. So if I put a negative value here, I will make this quantity to be equal. So sine of x maybe is 1/2. Sine of minus x should be equal minus 1/2. Minus this quantity will be minus 1/2 will be 1/2. So minus sine of minus x will be sine of x. This equation I think you know from algebra. If not, we will discuss more carefully. This is pre-calculus. Well, I have explained this, the absolute value function. The absolute value function does like this. It goes at 45 degrees. This is 45 degrees, or pi divided by 4. This angle should be pi divided by 4. So when it's 3, the height is 3. And when it's minus 3, the height is minus 3, is 3. Okay, this is the absolute value. Now we are going to solve all these 11 problems one by one to fix the idea and to try to make everything clear. Okay, let's go for the first one. Let's go to do problem 1. Problem 1 says, given the function x squared minus 5, which are the domain and the range. Okay, so we make a graph of the function. If we make a graph of the function, x squared minus 5 is a function that when x equals 0, y equal minus 5. So is minus 5. And this is the minimum value, because for any x that you will give as an input, the y value will be bigger than minus 5. For example, if you input x equal 1, the value will be 1 squared minus 5, which is minus 4. If you input x equal 2, the value will be 4 minus 5, will be minus 1. If you input 3, the value will be 3 squared, which is 9, minus 5, it is 4. If you input minus 1, it's symmetric. If you input minus 2, it's symmetric. The same value of y. And if you input minus 3, it's symmetric. So, for x equal minus 3, the function is 4. The value of the function is 4. So what is the graph? The graph is a parabola. It's a parabola whose minimum happens to be at x equals 0, y equal minus 5. So the domain is the set of all x. Domain is all real number, because the domain is on the x-axis and you can input any x number and you will have an output. Now the range is on the y-axis, and the range is, you see, the range will be all the y value from y equal minus 5 to infinity, is all y values such y is bigger than minus 5, is up of the minus 5, and is less than infinity. So, or in other words, you can put if y is bigger or equal of minus 5, there is an equal sign here, this is the range. Let's go to the next problem. This problem is very similar as the problem number 1. It says find the domain and the range of the function minus square root of x plus 3. So let's go to learn this technique. When you draw the function square root of x, the function square root of x will do like this. This is y equal square root of x. But I have a square root of x plus 3. Which one will be a square root of x plus 3? A square root of x plus 3 will be the one that is swept to the left 3 units. Minus 3. So it will be this one. And this is y equal square root of x plus 3. This is the function square root of x plus 3. So when x is equal 1, the height is 1 plus 3 is 4, square root of 4 is 2. So when x is equal 1, the square root of 4 is 2. And when x is minus 3 here, minus 3 plus 3 is 0, the square root of 0 is 0. So when x is minus 3, you are here. Now, the problem say not a square root of x plus 3. And now I have to make the picture of y equal minus a square root of x plus 3. Which one you think that it will be the graph? The graph is the same graph, but the y is negative. So it will start minus 3, but it will go like this. So when x equal 1, y equal minus 2. When x equal minus 3, y equals 0. And when x equal minus 1, it will be minus 1 plus 3, it will be a square root of 2. And what when x equal minus 2? When x equal minus 2, this will be 1. 1 negative, minus, minus, minus. So this is the graph, y equal minus a square root of x plus 3. So we have learned two techniques. The first technique is given this function, if it appears x plus 3, you switch the graph to the left 3 units. And this is the graph of y equal a square root of x plus 3. If it appears the minus sign, you rotate this graph through the x-axis, and it will appear this graph. And this is the graph of the function square root minus a square root of x plus 3. So what is the domain? The domain, what do you think it will be the domain? The domain is all x that what? Of x that are bigger than minus 3 are to the right of minus 3. For any x that you plug in here, you will obtain a y. And what will be the range? The range will be all y such what? That y is, you see, the range is here. You can arrive to any point in the y-axis. For this point x, you will arrive here. So the range is all y negative. Is for all y such that y is smaller or equal than 0. Oh, and the problem is done. Well, find the domain and the range of the function cotangent of x. the function cotangent of x do like this, and you should know based on the function tangent of x how you will obtain this graph. You see this graph contains here the 0. Here is the 0, the x-axis. Now this point is when cotangent of x is 0. And this point is when cotangent of x is infinity. When this graph, what is cotangent of x? Cotangent of x is 1 divided by tangent of x, or tangent of x is sine of x divided by cosine of x. 1 divided by sine of x divided by cosine of x is cosine of x divided by sine of x. No. So now if I want to find this point here happens to be when cotangent of x is 0, when the height is 0, and when cosine of x divided by sine of x is 0. When cosine of x divided by sine of x is 0 means that the numerator have to be 0, means cosine of x equals 0. And when cosine of x is equal 0, when x is pi divided by 2, comma, now you have to go around the circle. Pi divided by 2. If you go far, so you draw this unit circle, and when pi divided by 2 is here, the cosine is 0. The cosine, remember, is this part, is the adjacent. Now here is also 0. So this point is pi divided by 2 plus pi. Pi divided by 2 plus pi is the same that pi divided by 2 plus 2 pi divided by 2, or 3 pi divided by 2. So at this point, pi divided by 2 and 3 pi divided by 2, this is this point, and this is 3 pi divided by 2. Now, you see that the point is repeated to the left. This is minus pi divided by 2. And this is minus 3 pi divided by 2. At minus 3 pi divided by 2, the cotangent of x is 0. But here it says, what is the domain? The domain is all numbers x where you can find an output, the y. You see in the definition of the cotangent, because cotangent is cosine of x, is cosine of x divided by sine of x, when you cannot obtain any number, when the function is not defined. When the function is not defined, when sine of x is equal 0, because division by 0 is not allowed, doesn't exist. So when sine of x is equal 0, cotangent of x is the domain have to eliminate this point. When sine of x is equal 0, sine of x is equal 0 when the x is 0, or when the x is n pi. If the x is n pi, meaning 1 pi, 2 pi, 3 pi, or minus pi, minus 2 pi, minus 3 pi, at these points the cotangent of x doesn't exist. You cannot divide by 0. So the domain is all points such that x is different than n pi. The domain is all points such x is different than n pi. And the range, as you can see in the figure, is all real number. In the y-axis, you can arrive to any y that you imagine. All real number is the range. Let's go to do problem number 4. It says evaluate the function absolute value plus 1 that is defined when x is minus 1 and minus x plus 1 that is a rectilinear line when x is bigger or equal than 1. Let's go to do also a graph, and so we have to evaluate f of minus 3. Where is x equal minus 3? Is less than 1. So I will use the first rule, this one. So f of minus 3 is the absolute value of x plus 1. Absolute value of x plus 1. In this case, absolute value of minus 3 plus 1. What is the absolute value of minus 3? It's minus 3. Minus 3 is 3. 3 plus 1 is 4. So f of x equal minus 3, which is valid when x is less than 1, is this value. The other point is f of x equal 1. F of x equal 1 is not in the first rule for the function, is on the second, because you see the equal sign. When x equal minus 1 plus 1, when x equal 1, it will be minus 1 plus 1, so it will be 0. And what is f of 3? F of x equal 3, for the same thing, is when x is bigger than 1, it will be minus 3 plus 1. And minus 3 plus 1 is minus 2. Let's go to graph this function. To graph this function, we'll do the same idea that we did at the beginning in problem 1. This is the graph of absolute value of x. Okay, what will be the graph of absolute value of x plus 1? It will be the same graph, but you go up 1 unit. So here is 0, 0. Now here is the point 0, 1. So it will be a V like a V. And this is the graph of absolute value of x plus 1. But this is only valid when x is equal less than 1. So it's only valid in this region. So I need to erase this part. Now, what is the function minus x plus 1? Minus x plus 1 is a rectilinear line that when x is equal 1, y is equal 0. Oh, so it starts here. And it's the function whose slope is minus 1. So when x equal 2, minus 2 plus 1 will be minus 1. So it will be here, minus 1. So is this line. Is this line. Is the rectilinear line that does like this. So the value of the function is defined as x equal 1 here. And the function does like this. It goes like absolute value of x plus 1, where when x equal 1 is this function, this rectilinear function. So the third question that is asking who is f of b squared plus 1. F of b squared plus 1, you need to think a little bit. Should I use the first part of the definition of the function or the second part? Well, b squared, whatever is b, even if b is negative, minus 3, b squared will be positive. Plus 1 will be a number that is bigger than 1. So I will choose for x bigger than 1. So f of v squared will be the point x, this is the x is v squared plus 1, so it will be minus v squared plus 1 plus 1. So it will be minus v squared. And this is the correct answer. Let's go to do now this problem. It says sketch the function 1/3 x cubed plus 3 and find the domain and the range. So we apply the same technique that we have been using. Who is the function y equal x cubed? The function y equal x cubed does like this, and here has a slope 0 and does like this. This is the function y equal x cubed. When x equal 2, y equal 2 to the 3 is 2 by 2 is 4, 4 by 2 is 8. When x equal minus 2 is minus 8. Okay, this is the function y equal 1, y equal x cubed. Y of x equal x cubed. Who is the function 1/3 of x cubed? Well, it's the same function, the same one, but now the value of the y will be 1/3. So when x equal 2, the height will be 8/3. When x equal minus 2, the height will be minus 8/3. And who is the function 1/3 of x cubed plus 3? Well, plus 3 means that you put this point 3 units up. So the function 1/3 of x cubed, 1/3 of x cubed plus 3, 1, 2, and 3, and you graph the same function. Now let's say that you want to find this point. This is the point of intersection with the x-axis. How you will find this point? Well, you will say, well, this point occurs when the y becomes 0. This point occurs when the y becomes 0. Who is the point? Well, a little bit of algebra for your side will discover who is this point. So, to finalize the problem, the graph of the function f of x equal 1/3 x cubed plus 3 is this one. What is the domain? The domain is all real number. The domain is any real number will have a value y. What is the range? The range is all real number also. You can arrive to any y. So the domain is all real number, and the range is all real number. Let's go to the next problem. Determine whether the function f of x is cubic root of x is even or odd. A function is even when it happens like this. F of x is equal f of minus x. What it means is that there is a symmetry through the y-axis. So this is the x, so the point minus x is on the other side, and the value of the function is the same one. F of x equal f of minus x. For example, y equal x squared is an even function. Perfect. What is an odd function? An odd function is when f of x equal minus f of minus x. For example, the picture is like this. You choose a point, you obtain a value, y, f of x, for the point, and if you go to the point minus x, and you see the value of the function, and you change the sign, it will correspond to the same value of f of x. So the function have to be going down, let's say minus 3. So when f of minus x is minus 3, let's say that this is 3, when f of minus x is minus 3, with the minus sign will be positive, will be plus 3. So in this case, the function we will say that is an odd function. An odd function, for example, is x cubed. X cubed does like this. The slope is 0 and x equals 0, and do like this. This is an odd function, like x cubed. Now, is the cubed root an even or an odd function? Well, we can make we can draw the function. If you draw the function, you will find that the cubed root do like this. On here, the slope is 0. The slope is 0 here. No, the slope is infinity. Sorry. The slope is infinity, and we'll do like this. Now, f of x equal minus f of minus x. Okay, and this is an odd function. So a cubic root of x is an odd function. If you want to prove it, we have to say f of x will be equal to f of minus x with the minus sign. Who is f of x? F of x is the cubic root of x. Who is minus the f of minus x? F of minus x is the cubic root of minus x. Perfect. Is these things the same thing? Is a cubic root of, let's say, of 27 is equal to minus the cubic root of minus 27? Well, the cubic root of 27 is 3 by 3, 9. 9 by 3, 27 is 3. Now, the cubic root of minus 27 is minus 3, because minus 3 is the number that when I multiply 3 times, minus 3 multiplied by minus 3 will be plus 9. Multiplied by minus 3, it will be minus 27. So the cubic root of minus 27 is minus 3. So it's minus 3. Oh, so 3 is equal to 3. Is correct. So the cubic root of x is minus the cubic root of minus x. It means that the function is an odd function. Now we do the same thing. Who is f of x? In this problem, f of x is x cosine of x. F of x is x cosine of x. Who is f of minus x? Is replace x by minus x. Replace s cosine of the value that is here, of minus x. Now it happened to be that cosine of minus x is equal to cosine of x. So it's minus x cosine of x. Because if you go to the unit circle, you will realize that when you have the angle x, the cosine is the adjacent, and when you have the angle minus x, the cosine is also the adjacent. So you have two triangles. This is the x, this is cosine of x in the unit circle, and for the minus x angle, you have the same amount for cosine. So cosine of x is equal to cosine of minus x. Now the question is like this. What happened here? I can see that this is f of x, so this will be minus f of x, because x cosine of x is f of x. So what I have proved that f of minus x is equal to minus f of x. And this is saying that the function is like, it behaves like an x cube, for example. An x cube is an odd function. So this function is odd. So we write this function is odd. Let's go to the next problem. This problem say find 6 trigonometric functions. Find the 6 trigonometric functions corresponding to the angle pi divided by 6. So the angle pi divided by 6 is obtained when you do a right triangle, like this one. This one side is a square root of 3, the other side is 1, and now what is the value of the hypotenuse? The value of the hypotenuse is Pythagoras theorem, c squared equal a squared plus b squared. So c will be a square root of c squared will be 1 squared plus a square root of 3 squared. So c squared will be 4. Square root of 3 squared is 3. 3 plus 1 is 4. So c, it will be 2 is a length, so it's 2. So this is the right triangle. And for this triangle, you need to know that theta equal pi divided by 6. And in degree, what is pi divided by 6? Pi divided by 6 is 30 degrees. So it say, find the values of the 6 trigonometric function. The first trigonometric function is sine of pi divided by 6, sine. What will be the sine of pi divided by 6? Opposite divide by hypotenuse, 1/2. Opposite divide by 1/2. Cosine of pi divided by 6. What will be cosine of pi divided by 6? Will be adjacent divided by hypotenuse. So square root of 3 divided by 2. What will be tangent of pi divided by 6? Tangent of pi divided by 6 is opposite divided by adjacent. It's 1 divided by square root of 3. So you know that tangent of 30 is 1 divided by square root of 3. Now, which are the other trigonometric functions? Let's say secant, cosecant, and cotangent. Now, cotangent of pi divided by 6 is 1 divided by tangent of pi divided by 6. If you do pi divided by 1 divided by 1 divided by square root of 3, it will be a square root of 3. What will be secant of pi divided by 6? Secant of pi divided by 6, it will be 1 divided by cosine of pi divided by 6. So you flip the numerator with the denominator, it will be 2 divided by square root of 3. And cosecant of pi divided by 6 will be 2. I hope this problem is clear, and you need to know how to find the sine, the cosine, and the tangent of pi divided by 6. It should be something that is in your pocket all the time, and you don't need to use any calculator to do this. Problem 9 says use the identity sine squared plus cosine squared equal 1 to derive the identity tangent squared plus 1 equals secant squared of x. First of all, this identity, sine squared of x plus cosine squared of x equal 1, it comes from a squared plus b squared equals c squared. Because if you divide this equation by c squared, you will have a squared divided by c squared plus b squared divided by c squared equals c squared divided by c squared. So our triangle is here. A is a right triangle. B, all the trigonometric functions are defined on right triangles. The triangle should be. So what is A divided by C squared? A divided by C in this picture is cosine of theta squared. What is B divided by C? V divided by C is sine of theta, but it appears B divided by C squared, so it's sine squared of theta equal 1. So we have proved that this relation and the Pythagoras theorem are the same one. So now the problem is not asking this. The problem is asking, can you arrive to this equation from the identity, from the fundamental identity sine square of x plus cosine square of x equal 1? Can you deduce tangent square of x plus 1 equals secant square of x? Secant is the inverse of cosine of x. Well, if I want here to appear the inverse of cosine, I should divide everything by cosine. So if I divide the fundamental identity sine squared plus cosine squared equal 1 by cosine squared, I will obtain sine square of x divided by cosine square of x plus cosine square of x divided by cosine square of x equal 1. And now I have the identity. Sine square of x divided by cosine square of x is tangent square of x plus cosine square of x divided by cosine square of x is 1 1 divided by cosine square of x, and 1 divided by cosine square of x is secant square of x. So this is the proof that this relation sine square of x, cosine square of x equal 1, and this other relation are the same one. Okay, let's go to the last problem. Find all solution to the trigonometric equation on the interval 0 to 2 pi. Open interval 2 pi. So it means that the 2 pi is not taking. You can approach 2 pi as much as you can, but because it's an open interval, the 2 pi is not including in this interval. Because here is closed, the 0 is including, the 2 pi is not including. So how we will solve this problem? First of all, you will define a capital Y as sine of x, and you will write the equation with capital Y. So the equation will read like this: 2 times y squared minus y minus 1 equals 0. So now you will say I can solve by the quadratic equation for y. If I solve for y, capital Y, this quadratic equation, I will have y equal 1 and y equal minus a half. But y is sine of x, so the solution will be that sine of x is 1 and sine of x is minus 1 half. So y equal 1 means sine of x equal 1, y equal minus 1 half means sine of x equal minus 1 half. Now the question is, when sine of x is equal 1? When x equal pi divided by 2, because x, sine of pi divided by 2 is 1. When x equal minus 1 half, oh, this you know, because you know that sine of pi divided by 6 is 1 half, but here they say sine of something should be minus 1 half. So the angle should be minus pi divided by 6. So this angle corresponds to 2 pi minus pi divided by 6. So if I go to the unit circle to see the angle, this is the unit circle. So the sine of pi divided by 6 is this height. This is the sine of pi divided by 6. And if you go the same amount, let's go to draw the picture well, the same amount, let's go to make a better picture. So if you go to the unit circle and you go to pi divided by 6, this is the sine. If you go up minus pi divided by 6, the sine is the same height but in negative. It's going downwards. Now, this angle here is 2 pi minus pi divided by 6, because this is pi divided by 6 and this is also pi divided by 6. Okay, and where also the angle will be 0, the sine of something will be minus 1/2, not 0, minus 1/2. When the sine here, the sine of this angle will be minus pi divided by 6, minus 1/2. And what is this angle? This angle is pi plus pi divided by 6. Pi plus pi divided by 6 is the other angle. So I have one angle that is 2 pi minus pi divided by 6. 2 pi minus pi divided by 6 is 11 pi divided by 6. And the other angle is pi plus pi divided by 6, which is 7 pi divided by 6. As a conclusion, the solution to this equation, 2 sine squared of x minus sine x minus 1, have 3 solutions. The angle x could be pi divided by 2. The angle x could be 11 pi divided by 6, and the angle x can be 7 pi divided by 6. If you plug in any of these numbers into this equation, you will find a 0. Okay, let's go to the next one and the last one. So tangent of x equals 0. Who is x? Sine of x divided by cosine of x should be equal 0. When a fraction is 0, when the numerator is 0, when sine of x is 0. And when sine of x is 0, well, when x is equal 0. Also when x is equal pi, when x is equal 2 pi, 3 pi, 4 pi. So when x is equal n pi, tangent of x is 0.